Okay, so in this video, we're going to do graphing systems of inequalities. So it's not going to be much different than what we were doing in the last section and in the last unit. We've already graphed systems and we've already graphed inequalities. So now we're just going to combine those two ideas together. So first thing that you're going to want to do is make sure that all of your inequalities are in your slope intercept form, which is that y equals mx plus b, but it's not going to be an equals, it's going to be an inequality before you graph. And you are going to graph both inequalities on the same coordinate plane. The answer or solution will be where the shaded regions overlap. Okay, so some things to remember just with graphing linear inequalities. Again, this should be similar to last time. So again, make sure that all of your inequalities are in your slope intercept form, which is that y equals mx plus b before graphing. If your sign is either less than or greater than, the line is going to be dashed. If your sign is less than or equal to or greater than or equal to, then your line is going to be solid. So all of these graphs are going to need shading, which again should be similar from when we just were graphing just inequalities, not systems of inequalities. So you are going to test a point. Usually it's that 0, 0 point. Unless your line goes through that point, then you cannot use that to see which side of the line to shade. So if your test is true, you're going to shade to cover your test point. If the test is false, shade on the side of the line that the test point is not located. Okay, so to see how many solutions the system has by looking to see how many times the shaded regions of the graphs overlap each other. Oops. Okay, let me know if you have any questions on that. Well, let's do some examples. Okay. So I'm going to do these in 2 separate colors so that you can see which line is which. So this top one I am going to do in red. Okay. So first thing that we have to do is get your equations in y equals mx plus b form. So I'm going to have to take this and change this because this is not in that form yet. So x plus y is less than 2. So I'm going to start by subtracting x on both sides. Now I can't combine those because the 2 doesn't have an x, so it's just y is less than negative x plus 2. So this line is going to be dashed. So I'm going to start at the positive 2. And I'm going to go down 1 and over 1 all the way across the graph. Okay, so then I'm going to test my point. So I can test 0, 0 because it is not on my line. So I'm going to test 0, 0. So if I plug in 0 into this equation right here, so 0 is less than negative 0 plus 2. Well, negative 0 isn't a thing. So 0 is less than 2, which that is true. So I'm going to shade to cover my point. Okay. So I'm going to do this bottom equation in green. And as you can see, so far nothing has changed from what we did in the last unit. So I'm going to do this bottom equation in green. This one is already in our y equals form, so that's one less step that we have to do. But this one as well is dashed. And I'm going to start at the positive 7. So 1, 2, 3, 4, 5, 6, 7. Then I'm going to go up 4 and over 1. 1, 2, 3, 4, and over 1. 1, 2, 3, 4, over 1. 1. I do suggest using some sort of color because that makes it a little bit easier, but it's not required. So again, this one is dashed. And again, I can test the 0, 0 point because that is not right on my line. So 0 is greater than 4 times 0 plus 7. Well, anything times 0 is just 0, so that's going to cancel out. So 0 is greater than 7. Now that's false, so we're going to shade not to cover our point. So that's over here. So then our answer is going to be where our two regions overlap, which is this area right here. Now you do not have to mark this off like I am right now. I'm just showing you that that is your answer. So you're not going to have like a straight point answer like you did in the last section. It's going to be a whole area of your graph. Okay. So I'm going to go ahead and do another one for us. My green was dying though, so let's use some different colors. So let's do pink and purple. So I'll do this top one in pink. Okay, so this is already in slope-intercept form, so we don't have to manipulate that at all. And then this is going to be a solid line. So this is where we cross our x-axis at +1, which is right here. So it's just going to be a straight up and down solid line at +1. So I can test our 0, 0 point because it doesn't fall on our line. So 0 is less than or equal to 1, and that is true. So we're going to shade to cover our point, which is everything over here. Okay, then we're going to do this bottom one in purple. So this one though, we have to put in y equals form first. So I'm just going to start by subtracting the 2x on both sides. So y is less than -2x plus 4. Then this is going to be a solid line, or sorry, not solid, dash, because there is no line underneath that. So I'm going to start at the +4, so 1, 2, 3, 4, and go down 2 because it's negative, 1, 2, and over 1. And up 2 and over 1. And again, I can use that 0, 0 point to test. So 0 is less than -2 times 0 plus 4. That will just cancel. So 0 is less than 4, which that is true. So I'm going to shade to cover my point, which is everything over here. So my answer is where they overlap, which is this entire region over here. Okay. So I want you to do these bottom two. And the two up on the top. Let me know if you've got any questions.